Select 2 ice cubes and ensure that they are similar in size and shape. Place an O-ring on each ice melting block. Observe the ice cubes as they melt. Place 2 timers next to each ice melting block in order to have an accurate measurement of how quickly each ice cube melts.
The term thermodynamics refers to the branch of physical science that deals with the relations between heat and other forms of energy. There are 3 laws of thermodynamics. The first law, also known as the law of conservation of energy, states that energy cannot be created or destroyed in an isolated system. The second law of thermodynamics states that the entropy of any isolated system always increases. The third law states that the entropy of any system approaches a constant value as the temperature approaches absolute zero. In this PBL, variations in thermal conductive capacity are largely to blame for the difference in melting rate between ice melting block number 1 and ice melting block number 2. Over the course of several weeks, I recorded a series of journal entries, each of which focused on a different aspect of the experimental process. The following is an excerpt from journal entry number 7. The experiment, which was comprised of observing ice melt on 2 different ice melting blocks, did not take more than half an hour. As expected, the ice cube located on the wooden block melted much more slowly than the ice cube located atop the metal block. According to Mr. Kalesh, this occurred because metal has a higher conductive capacity for thermal energy. Thus, energy was transferred more readily and the ice cube melted more quickly. Thermoeconomics is the application of thermodynamic principles to economics, as well as the application of principles of economics to the efficient design of engineering and industrial processes. The term thermoeconomics was coined in 1962 by American engineer and professor Myron Trebus. Though the term itself was coined in the early 1960s, the idea of linking the laws of energy to cost flow emerged soon after the Second World War. However, the theory was largely rejected until the early 1980s, the decade in which the vigorous application of thermoeconomics to the analysis, optimization, and design of thermal systems began in earnest. Today, thermoeconomics is applied in many different ways. For example, it has been used in the analysis of fuel decarbonization and carbon dioxide separation plants. Consequently, it has also been utilized in the reduction of environmental impacts resulting from increased concentrations of greenhouse gas emissions, which are widely held as being responsible for global warming.